We are looking at 2-8 notes part 1, and we are solving absolute value equations. The next section will be solving absolute value inequalities. So when I ask you to consider the following equation, what are these bars around the x?
Absolute value.
Absolute value. So when I say what's the absolute value of 3, you would tell me the absolute value of 3 is 3. And if I say what's the absolute value of -3, you would say the absolute value of -3 is also 3. What does that really mean? What does absolute value mean? Okay, some people say it's always positive, but it's really the distance away from 0. A negative number is to the left of 0, and a positive number is to the right of 0. So when I'm asking you, what can I take? I'm asking you, what can I take the absolute value of and get a 7? Well, I can take the absolute value of 7 or -7, and I will get out 7. So we need to make sure that we remember that absolute value is the distance away from 0. Absolute value is the distance away from 0. That's what we're talking about. Now, if I have the absolute value of x equals -4, what could x be? That's no solution. When you take the absolute value of number, it's the distance away from 0, so it should be positive. So -4 is 4 units to the left, but you don't have that as an option. So if your absolute value is isolated and it's equal to a negative number, this is impossible, okay? Distance away from 0 as -4 is impossible. It is impossible for the distance away from 0 to be a -4. From 0, it's impossible for the distance away from 0 to be -4. Now, I know someone's saying, but -4 means left 4, but the distance can't be -4. The direction is negative. Got it? So your absolute value cannot equal a negative number. Okay, so if you isolate the absolute value and it's equal to negative, then we're saying there's no solutions. But you have to isolate it first. So look, here are the steps to solve absolute value equations. Isolate the absolute value expression. So it could be one item or it could be an expression in the absolute value. Create two cases, the positive or the negative value. So we're going to solve two different equations, solve both equations, and this is important. We have to check for extraneous or the other word is erroneous answers. There can be false answers. You're going to get an answer and it's not going to work. All right, now what's the definition of an extraneous solution? It's a solution that emerges while solving an equation, but it's invalid. So let's write that down. A solution that emerges, or basically you get a solution while solving an equation, but is invalid. So you will have to check your answers. You got to check them, otherwise you won't know if it's an extraneous solution or not. First equation, notice that the absolute value is isolated. So I'm saying what's inside is equal to 3 or -3. That's what I want you to think about. These little absolute value signs are like armored cars. You don't get to change what's inside. You don't distribute to them. Nothing in, nothing out. So what I'm asking you is, what can I take the absolute value of to get 3? A 3 or a what? -3. If I just said the absolute value of x equals 3, you would say, hey, what's inside could be 3 or it could be -3. So see how I'm saying the what's inside? What's inside is 2k plus 7. That could equal 3, or what's inside stays the same, could equal a -3. I need to figure out what k value will make this be a 3 and what k value would make this be a -3. So absolute value of 3 is 3, absolute value of -3 is 3. So that's why we set the inside equal. And then you're just going to solve them. Yes, we're doing the same thing when we solve them. 2k equals negative 4. Divide out the 2, k equals negative 2. Or subtract 7, but I'm going to get a different outcome. This time 2k equals negative 10. Divide by 2, k equals negative 5. Now this looks good, but you can't just leave this answer. You have to check them. So how do I check them? Before I say I'm done, I'm going to check them by plugging them back in. So I'm going to go back to the original with the absolute value and do 2 times negative 2 plus 7. That should be a bracket there. I don't need the parenthesis. And it should equal 3. All right, well, isn't this negative 4 plus 7? So there's my positive 3 equals 3. Is that true? Okay, so the first one works. Oh, I'm out of room there. All right, now look at your second one. Absolute value of 2 times negative 5 plus 7. Make sure your absolute values don't look like ones, is equal to 3. When you do absolute value, you follow all the rules. You do what's inside like it's in parentheses. So clean up the inside, negative 10 plus 7. So you are going to add this. You don't just go in and change signs. Negative 10 plus 7 is negative 3. What is the absolute value of negative 3? 3 equals 3. So both answers work. So I am going to circle them. So every problem you do, you want to check your answers in the originals. All right, now, the look at number 2 here, the first thing I need to do is isolate. Someone's going to say, well, it equals a negative, there's no solution. I've got to isolate the absolute value, which means get rid of that divided by negative 2. So how am I going to do that? Multiply both sides by negative 2. Now this is to cancel. It doesn't distribute. We canceled it. And now I have the absolute value of y minus 10 is equal to 12. This I can do, right? Your problem starts here. This is where we make the two cases after you isolate the absolute value. So what's inside y minus 10 could equal 12, or what's inside could equal negative 12. I mean, if you think about it, I could take the absolute value of 12 and get 12, or the absolute value of negative 12. So we set that inside equal to both pieces. Simply add 10, y equals 22, or add 10 and we get y equals negative 2. All right, before you're done, you have to check your answers. So when I go to check, I'm always going back to the original. So check my 22, it'd be 22 minus 10, all divided by negative 2. When I do the math, I treat this like it's in parentheses. The top is going to be the absolute value of 12 divided by negative 2. The absolute value of 12 is 12 divided by negative 2, and I do get negative 6. So it works. Check the other one. Take your negative 2 and plug it in. So you do everything in the absolute value, and then the last thing you do is take the absolute value. So negative 12 in the absolute value signs. Does it work? Yep, the absolute value of negative 12 is 12. What's 12 divided by negative 2? Negative 6. So both answers are good. I have no extraneous solutions. All right, go ahead and flip it over. First thing we're doing is isolating. So we need to get rid of 16 by dividing it out. The absolute values are staying as r minus 5 equals negative 2. Well, I'm done. Why am I done? Can my absolute value ever equal a negative number? No. If you would try to solve this because you forgot and you would do like a negative 2 and a 2, and you would test your answers, you'd find out it won't work. There's nothing I can put in here. 7 minus 5 is 2, and the absolute value of 2 is not negative 2. No matter what I put in here, I can't get out the absolute value of it to get a negative 2. So there's no solution. The work you should show is isolating it first. If this was a negative 16, it would be fine because then it would equal positive 2. So always do the work first. What's different in number 4 here? There's more stuff over here, right? There's 2 terms over here. Okay, so what's inside would equal a positive outcome, or what's inside could be a negative outcome. Agree with that? So when we do this, I'm going to show that 3x minus 9, when I say a positive outcome, it's the number as it is. So if this was x minus 1, it would stay. Nothing changes. Or what's inside could equal a negative outcome, and it's going to be the opposite of the whole answer. So this is like the positive outcome, and this is the negative, but I have to distribute it. So that's what's different. We keep the answer, and we take the opposite of everything. So this one, I could just start solving. I'm going to bring the x to the left. I do prefer to move the x first. And then I will add 9. So 2x equals 10. What does x equal? 5. All right. This one, I have an extra step because I want to make sure that I distribute that negative sign. I'm going to add x. And I have 4x minus 9 equals negative 1. Add 9. 4x equals positive 8. So what is x? 2. So I need to check it before I determine my answer. Go back to the original. The absolute value of 3 times 5 minus 9. Is that equal to 5 plus 1? All right, well, that would be 15 minus 9, which is 6. What's the absolute value of 6? 6 does equal 6, so I'm happy with that answer. Take your 2, plug it back into the original. We use the original because we need to test the absolute value. Everywhere there's an x, put your 2. This would be 6 minus 9. The absolute value of negative 3 is 3, and that equals 3. So both answers work. X is 5 or x can be 2. Both answers work for this problem. All right, next one. Same deal. There's a number outside, but also a variable on the other side. So the first thing I need to do is we cannot distribute. Nothing in, nothing out. Whatever's in the absolute value will always stay in the absolute value. You can't change it. So I'm going to divide out the 2. Now I've got my absolute value isolated. And now we can start the problem. First thing I'm going to do is determine that what's inside is going to stay, but it could be the positive answer, or what's inside could be that negative 7h. And I'm going to move the h over by subtracting it. And yes, I'm going to end up with a fraction dividing by 6. So I'm going to have h equals 4/3. So make sure you reduce your fraction if you have one. This one, I'm going to subtract the h. And I end up with 8 equals negative 8h, divide by negative 8, and h equals negative 1. So I need to check my answers. So this is the next step. Go back to the original before you changed anything. And this is not an option. Like, you have to check because you're going to see one of these answers does not work. So I'm going to have 2 times the quantity, 4/3 plus 8, close absolute value, equals 14 times 4/3. Okay, I'd probably be using a calculator to crunch these numbers, and I get 2 times the absolute value of 28/3, and that is going to give me over here, if I multiply, 56/3. And when you multiply fractions, I can put this over 1, you multiply the tops and the bottoms. When I add, I need a common denominator, so that would have been 24/3, and there's a 28/3. Anyway, you cut it, this ends up being 2 times 28/3. Equals 56/3. Again, you can use your calculator, but 2 times 28 happens to be 56, and then over 3. So this one works. We're happy with that. All right, then we're going to check the other one, which is 2 times negative 1 plus 8. And I can tell you right now, it's not going to work because I have this absolute value equal to negative, and that's a positive 2. But let's go through it. The 2's out there. We end up with a positive 7 equals negative 14. Well, isn't that 2 times the absolute value? So 14 does not equal negative 14. I want to test it because if this was a negative 2, then we'd be in good shape. That answer doesn't work. So when you're turning something in, you need to be very clear. I should still have this work show my answer, and then circle or rewrite the answer that did work. Now, why do I want to make sure I show my work and show my check? If my answer was wrong and it doesn't work, that makes sense. So I would at least still get some credit because I showed why I threw it out. Okay. All right. So some answers won't work. Now, look at the next one. I need to isolate it by adding the 5n. So 8 minus 2n is equal to, so if you want to show this to help you, if it helps you put a little 1 there, I have 6n plus 2. So we're going to look at the two cases. The positive case, we leave what's inside alone, and it could be the positive outcome, or we look at what's inside if it had the negative outcome, and we need to make sure that we distribute that negative sign. So this negative sign is changing all the signs in there. All right, so go ahead and clean this up. I'm moving this to the left. Maybe you don't like that. Whatever works for you. At the same time, maybe you move the 8 by subtracting it. So I have negative 8n equals negative 6. I'm going to divide by negative 8. I think sometimes it helps us to show that so we don't flip our fraction, and we should get a positive 3 over 4. So that's my first outcome. Then when I do this, I'm going to take the time and I'm going to rewrite this negative sign so I don't lose it. And then I will add the 6n. And at the same time, I'm going to subtract the 8. If that's more than you want to do at once, that's fine. I get a positive 4n. That's gone. That's gone. And I get a negative 10. Divide by 4. So I end up with n equals a negative 5 halves. So there are my two answers. So I'm going to do my check. It is part of my work. 8 minus 3/4 times 2. And then minus 5 times 3/4 equals 3/4 plus 2. Do you notice that I went back to the complete beginning? Okay, so we can type this into the calculator. We can crunch some numbers. I will show this real quick. It's okay. So if I wanted to put this in the calculator, I'm going to go to my math key, hit math, go over to number, and there's my absolute value sign. And I'm going to do 8 minus 2, and then I could use parentheses, or I could use the time symbol, and then I'm going to do my fraction button to do 3 over 4. It's probably taking me just as long to type this in, and then minus 5, and again times 3 over 4. Okay. I guess I have an extra parenthesis there. There we go. So I get on this side 11 over 4. That's all of this. And I want to do 3/4 plus 2. Well, 2 is the same as 8 over 4, which also is 11/4. If you want me to show that to you, again, we would just do 3/4. Make sure you get out of the denominator plus 2, and there's my 11/4. So the first answer works. I'm happy with that. And then we're going to check the second answer. It is more time consuming. When we have fractions, it's also, a longer equation. All right, so I'm going to go ahead and plug it in. We can use our calculators for this. Notice it's minus 2 and a negative 5 halves. Absolute value signs close. Minus 5 times negative 5 halves. And we want to see if that equals negative 5 over 2 plus 2. If I wanted to, I could arrow back up to my old one. Okay. I can hit enter. It pops it down here. Now, I need to change my fraction, but I also need to insert a negative sign. So there's my negative sign. And what am I doing? 5 over 2. And everything else should stay the same. But same deal here. I'm going to insert a negative sign and then 5 over 2. So there's my equation. On this side, I get 51 over 2. Over here, I have negative 5 over 2. That is not going to be the same. So if I do negative 5 over 2 and I add 2 to it, I end up with negative 1/2. These are not equal. I didn't make a mistake. That answer is being thrown out, so clearly showing my final answer. So you need to show the check, but you can put it in the calculator, but then finalize your answers. And what is this called when it's not right? It's a false answer, or we could use the word extraneous, or you could see the word erroneous.